It's great to be back. I'm Lawrence Krauss, the director of the Origins Project, and I'm very excited, but not just about tonight, but about the events we're having this spring. I should apologize. My voice may go. I just returned from Davos, Switzerland, and I got rich people's viruses, and they're very pervasive. But there are a number of firsts this spring, and that we've never done before. And in a little over a month, I should tell you, we're having a two-day event here, two separate events here, involving our origin stories theme. And they are going to bring a lot of interesting people here, including Richard Dawkins, the novelist Ian McEwan, my friends Neil deGrasse Tyson, Brian Greene, Ira Flato, and several special guests from Hollywood. And associated with the panels and events we're going to have will be a gigantic test screening of a brand new feature film that you'll be the first people in the world to be able to see and comment on if you come. So I encourage you to look forward to that. That's March 29th and 30th, and that's Good Friday, so it's an easy day to remember. Now, this event is a first in another way. We've had a lot of, I'm very proud of the events we've had here in Gammage, with our partnership with Gammage, and we've talked about the origins of life and morality and deception and xenophobia. But one of the things the Origins Project is about, and I'm hoping it'll become more about, is the origins of the future. And this event perhaps discusses a subject, probably the most important subject I can think of globally for our own future. And what we've done, as we often do with several of our public events, is organize a workshop to bring in the world's greatest scientists to discuss topics of interest. And we have brought together an amazing group of scientists that's just spent the day talking about climate change and informing each other about the major issues, and more importantly, what we may do about it as a civilization. And so we're very lucky because of that event that we were able to have an amazing crew of experts and intellectuals to bring to you today. And I want to call them out on the stage right now, so if they can come out, it'd be great. Great, you have a seat. So the title of this event is indeed up there, Climate Change, Surviving the Future. And surviving the future is very important. I have several hats, and one of them I'm proud of is I'm chair of the board of sponsors of the Bulletin of the Atomic Scientists, which was founded in 1946 by Robert Oppenheimer and Albert Einstein, to warn the public about the dangers of nuclear war. And a few years ago, we added, when we thought about doomsday, we added, which is a subject we do once a year, it's a very pleasant event I go to, we added the idea of climate change. And some people, we got a lot of flack about that, because people said, well, it's not an urgent problem, it's the future, it's not. But in fact, none of that is true. Perhaps there's no more urgent and clear problem. It's not a problem we're foreseeing for the future. It's a problem of the present time, as you'll see tonight in a variety of ways. And it's a problem we have to deal with urgently. Now, you wouldn't know that from the presidential election we just went through, where it wasn't discussed at all. Instead, and in fact since then, what we've heard is a lot of discussions about fiscal cliffs, which we've created and then avoided. But in fact, there's a climate cliff, and it's a climate cliff we've already walked off. And the question is how soft our fall will be. And that's what we're going to talk about, because it's not a matter, climate change is not a matter of the future. It's a matter of the present. It's happening now. And the question is, what can we do as a nation and as a civilization to try and address the urgent problems that it presents? You wouldn't get that from the media. That you get the illusion that climate change involves models, uncertain models of complicated systems and uncertain predictions about the future. But in fact, it's based on data today, as I'll introduce and our panelists will add to. The urgency of the problem is perhaps matched only by the difficulty of the solution. And two things, for example, today that came up that really hit me. And one is that if we stop producing carbon dioxide in the atmosphere today, the temperature rise that occurs because of it will last for the next 1,000 years. If we don't do anything to get rid of carbon dioxide, the carbon dioxide we've already created in the past. So even turning off all of human industrial activity today would produce a temperature change that will last 1,000 years. If we wanted to convert from fossil fuels to electricity, just generating enough electrical plants to try and take over the increased energy needs would require probably 100 years of construction. So it's not a problem that's going to be addressed simply, easily, or quickly. But I want to just present to try and overcome some of the myths in the media. I just wanted to present some of the data, because data doesn't lie. Politicians do. And the notion that the climate is changing due to carbon dioxide has been around for a while. And in fact, Charles Keeling, who used to be at the Scripps Institute, and began to measure, looking at measurements of carbon dioxide, and these measurements have been carried on to the present time. Realized that the carbon dioxide level, and carbon dioxide is a greenhouse gas, has been increasing at a rate consistent with human industrial activity, and it's been continuing to increase. And that is measured and clear. Now, the impacts of that are becoming more obvious every day. But for those who say, well, the climate change is kind of natural and it's not related to carbon dioxide, we know carbon dioxide is already having other effects, not just global warming. For example, if you pump up the amount of carbon dioxide in the atmosphere, more of it gets dissolved in the ocean in the form of carbonic acid and turns the oceans into more acidic levels. And in fact, you can see it here, but I think in the next slide you can see a little bit better. The oceans have been already, during the same period as the carbon dioxide has been seen to be raising, have already become more acidic. And as they continue to be more acidic, eventually coral and anything with shells, which in fact dissolves in that acid, calcium carbonates will dissolve in it, will go away. And at some point in the foreseeable future, the oceans will not support the kind of shell life that they now do. The oceans have already begun to enter Oceans 2.0, but so has the Earth. The Earth is, the response to the increased carbon dioxide in the atmosphere is already apparent. And it's apparent in a number of ways, and for a long time people have been worried about the ice loss of the Greenland ice sheets, because of course if all of the Greenland ice sheets melted, it would change the water levels on the Earth by meters. But it's already been measured again from 2002 to 2005. You can already see it. But as I'll talk about, it's been getting worse. It's increasing. The ice loss in Greenland is increasing, and recently it's become clear that also the ice sheets in Antarctica are also melting at an increasing rate. That's data, not predictions. And people worry about what may happen if you look at the ice sheets in Greenland, because of course a lot of this can be nonlinear. As the ice melts, water flows down. Water provides a lubricant underneath some of the ice sheets, and you might get catastrophic melting at certain points. That's, of course, a prediction. That's a possibility. But it's a possibility. The very fact that it's a possibility is something we should be worrying about, in my opinion. Sea levels are predicted to rise, but they're actually rising. It's not as if it's just a future problem. Sea levels have already been rising, and as I'll mention later, since the 1990s, have already risen half an inch. Now, the rising sea levels are already causing problems, but what worries me is something a little bit more. And the fact is, we also have data on the history of the Earth and the climate variation that has taken place before people. And by looking at Antarctic ice cores, we can try and measure both the carbon dioxide in the atmosphere and the temperature, and use physics models, in a sense, to try and explain, understand the temperature variations that have taken place. So this is 400,000 years ago all the way to the present. And you can see that there have been variations in the temperature by several degrees. The interesting thing to me is that the calculated temperatures, based on the same kind of models that are predicting the future, fit the data very well. But what's important is during this entire period, essentially, the carbon dioxide levels didn't approach what we have now. And independent observations of sea levels during this period, from the Red Sea, during the same period of climate variation, show that sea levels didn't just change by inches or centimeters, but by 100 meters. And at no time during this period, especially the recent period when we see changes by a large amount, has the carbon dioxide levels in the atmosphere been within a factor of 2 of what they are at the present time. So when we talk about sea level change, well, it may just be meters, but that, of course, will get rid of the land mass for over 2 to 3 billion people on Earth, people who, as I'll describe, can't afford to move and have no place to move to. But it could be much worse. And is that a risk we want to deal with? Okay. In 2012, the Wall Street Journal, which is no friend to the science of climate change, even the Wall Street Journal reported that a study in Science that improved accuracy demonstrated definitively that the polar ice sheets are melting at an increasing rate in both Greenland and Antarctica at a rate, and I found this particularly important, that cannot be explained by long-term climate variation. The sea level has risen 1/2 inch since 1992. 30% of that sea level rise is due to polar ice melting. The rest is due to the fact that water expands when it gets warmer. So both those effects are important, and they're included in the models. The ice lost in Greenland, this is the acceleration. It's not a small level of acceleration. It's now 5 times what it was in the 1990s. And the point is that this vindicates the models, which also tell us that global warming isn't uniform over the whole planet. It will affect different regions differently. And in fact, it was predicted that Greenland would be affected more than Antarctica, and that's what we're seeing. The National Oceanographic and Atmospheric Administration has reported several things. In particular, for those of you in the audience who are 27 years or younger, you have never experienced a single month of your life in which the global temperatures have been colder than the average temperatures over the entire period over which such temperatures have been measured. So every day of your life, every month of your life, the universe has been warmer, the Earth has been warmer than average. October 2012 was the 332nd consecutive month that the world has experienced above average global temperatures. So it's just like, what's his name, in Minnesota? Who am I talking about? Garrison Keillor, yes, where all children are above average. That's what's happening. And as we just learned, in fact, a week or so ago, it was reported that 2012 was indeed the warmest year on record for the lower 48 states, 3.2 degrees above the 20th century average. And as I want to stress, this does not imply that it's going to be the same everywhere. Britain, for example, experienced the coldest October since 2003, and there's a reason for that. As the Earth warms, ocean currents change, and so does the weather. In fact, Wally Broecker, who will maybe come up later and help to organize this meeting, and some people call him the grandfather of climate change. I call him the godfather of climate change, having worked with him a little bit. Northern Europe's going to get colder because of ocean currents, and that's already happening. But as I learned from Susan Solomon, the first time I listened to her, the saddest thing, perhaps, is that the worst effects of climate change will take place probably in the equatorial regions. Those are the people who are going to suffer the most, and they're the people who've been producing it the least. Because in those equatorial regions are most of the world's poor, who will lose not only their habitat, but in many cases their lives. And it becomes an ethical issue of the fact that the production of carbon dioxide has happened in a different place than for the most part, than the effects are going to happen. And that we may discuss. I don't know if Susan will discuss it. To add insult to injury, in spite of all of this, in spite of the talk of climate change and the dangers over the last 20 years, the Global Carbon Project reported that global emissions of carbon dioxide were the highest levels ever in 2011. They're not decreasing, and in fact, 2012 is likely to be another record year. So in spite of the dangers, we're continuing to produce that greenhouse gas at an ever-increasing rate. And as we'll point out, we've probably passed the point of having a reasonable probability of limiting the planet's temperature to 3.6 degrees by cutting carbon production alone. That goal was established a few years ago as being a catastrophic level of global warming. We've probably already passed the point. Because the key point, the reason the Earth will remain warm for 1,000 years, is that climate change doesn't go away when you stop producing carbon. It depends on the cumulative production of carbon over all of history, and we've already produced a tremendous amount. And even cutting it off today will have limited effects. So in fact, to have a 67% chance of attaining the goal of just 3.6 degrees would have required a 3.7% reduction if reductions had begun in 2011. That has already passed. And this is why it's urgent. Many people say, well, we can wait till we solve our economic problems before we have to address this. Let's just wait. Every year we wait, it gets worse. If it had begun in 2011, 3.7% reductions, which is a technological challenge. If they begin in 2015, we'll have to reduce carbon production by 5.3%. And if we wait till 2020, it'll be 9% per year, which is almost unimaginable. It is extremely unlikely, given the fact that there is no political global effort at this point to reduce carbon production, that we'll get to those numbers. And that means we have definitely entered Earth 2.0. So the question is not, will there be climate change? The question is, what can we do about it? And that's why we've assembled this sterling panel today. Okay, that's my introduction. And the way we're going to do this, and those of you who have been here know how we generally do these things, is each of our speakers are going to talk for a few minutes, and then we'll probably have an intermission. And before the intermission, most of you have been handed out cards for questions. And the way we're going to do questions this time is if you write down your questions, and we'll have people at the front getting them. During the intermission, please bring them down, and then we'll select some questions. And then when we come back, we'll have a general discussion among the panel here, and then we'll turn to audience questions. So that's where we're going to go. But the first person all my notes are over here. I want to get them. The first person I'm going to have speak is Jim Hansen, who was, for me, a very important figure because I guess I never appreciated the urgency of climate change until I first heard Jim talk. Jim is chief of NASA's Goddard Institute for Space Studies and a faculty member at Columbia's Earth Institute. He has, for a long time, probably been the scientist speaking out most forcefully. He taught Al Gore everything he knows, and more, perhaps. And he was just telling me beforehand that he has 5 sisters, is that right? So I think that's probably one of the reasons you become especially sensitive. So.
Thanks very much. And I'm glad that you've talked about the climate science, because I don't really want to talk about the climate science. The science is clear. It's, do I have a chart? Yeah, I have my first chart. In fact, I think this is the only chart I'm going to show.
Here, in case you need it.
Thanks. We have burned only a small fraction, the purple part, of the conventional oil, gas, and coal. There's a lot more that's in the known reserves, and then there are more resources which are less well known and it's unclear how much it will cost to get them out. And then there's all this unconventional oil and gas, tar sands, tar shale, fracking to get gas, a tremendous amount of potential carbon in those unconventional fossil fuels. With regard to the science, so we have already got climate change underway based on just this fraction of the fossil fuels that we've burned. And we have only realized about half of the warming due to the gases that are already in the atmosphere because of the tremendous inertia of the climate system. The ocean is 2.5 miles deep. It takes it a long time to warm up in response to the changes in atmospheric composition. And so as a result, it's still warming up. There's more energy coming in than there is going out from the planet. And so we know that there's about as much warming in the pipeline. And already we can see things happening based on the 0.8 of a degree Celsius, 1.5 degree Fahrenheit warming that has occurred. But what's really of concern is what will happen in the future if we continue to burn fossil fuels. Particularly the irreversible effects. The ice sheets, we know from the Earth's history that if we continue to warm the planet, we're going to get sea level rise of many meters, which means that all the coastal cities around the world are eventually going to go underwater if we follow that path. It's a little hard to say exactly when the ice sheets go unstable and lose mass rapidly. The other irreversible thing is the impact on other species on the planet. We're going to drive a significant fraction of the species to extinction. Scientists talk about biodiversity, but what they mean, loss of biodiversity, they mean some species are going to go extinct. And the estimates are that if we stay on business as usual, we could lose as many as 20 to 50% of the species on the planet. But it's not to say that, and that is something which will be a tremendous intergenerational injustice, because we're the ones who are putting the stuff in the atmosphere which is going to cause these problems over coming decades, but it's our children and our grandchildren who are going to suffer most of those consequences. Not that there aren't some things happening now. We know that global warming causes more extreme local and regional weather. The more extreme heat waves, droughts have become more extreme because of this increased heating, and wildfires that go with that become more severe and more frequent. But also the other side of the hydrologic cycle, when you do get rain, because the atmosphere holds more water vapor, you get a stronger floods and more heavy rainfall. But given this situation and the knowledge that we have to phase out these fossil fuels, what are we actually doing? The governments are actually allowing and encouraging us to go after every fossil fuel that can be found, including ones that are much dirtier, like the tar sands and the tar shale, and methods of extraction which are very polluting, mountaintop removal, longwall mining of coal. But why do we do this? It's because fossil fuels are the cheapest energy, or at least they appear to be the cheapest energy. And that's partly because they're subsidized, but mainly because they are not required to pay their cost to society. There's a lot of human health effects of air pollution and water pollution. If you get asthma or other things, illnesses associated with this pollution, you have to pay those bills yourself. The fossil fuel companies don't do that. and the climate effects. When there's a $60 billion bill associated with storms in the East Coast, or the extreme drought also had big bills associated with that. Those are borne entirely by you, the public, the taxpayers, not by the fossil fuels, the fossil fuel companies. So what we need to do to solve this problem is include these externality costs in the costs of fossil fuels by collecting a fee from the fossil fuel companies, which would have to start out modest and because you don't want to suddenly cause big problems to the economy, but actually the economy will do much better if things are priced honestly. So we need to add a fee to fossil fuel that we collect at the domestic mine or the port of entry, and that money that's collected should be distributed to the public, because the fossil fuel companies are going to increase the costs of energy, and therefore, so that the public is able to deal with this, you give the money on a per capita basis, uniformly distributed to all legal residents of the country. If you did that with the present distribution of energy uses, more than 60% of the people would get more in their dividend than they would pay in increased prices. If you want to stay, and if this price would need to continue to rise over time, and if you want to stay on the good side of the equation, you will have to watch your fossil fuel use and make the changes in your lifestyle and in your vehicles and whatever to keep your fossil fuel use on a downward path. And if you, just for example, if we started at $10 a ton and increased of CO2 and increased that $10 a ton each year, at the end of 10 years it's $100 a ton, which is equal to $1 a gallon on gasoline. But with the current fossil fuel use, that would produce $600 billion a year. You distribute that to the legal residents, and it's between $2,000 and $3,000. So you would have the wherewithal to make the changes. Now, and this, a simple, honest price on fossil fuels, on their carbon content, is the only realistic way to get an international agreement. You can't ask countries to have some target and expect them to achieve that. We found in the case of the Kyoto Protocol that doesn't work. You need to have this economic incentive. So finally, we have to have this, we have to have the public understand this. And the thing is that if we have such a system, we have the potential, this would provide the incentive for entrepreneurs to introduce low carbon and no carbon technologies. And we have the capability, the captains of industry with the abilities to lead this, and the venture capitalists who would provide funding. What we would like is the private sector to address this problem, and that's how we could do it, by providing that incentive. But we need to have this explained to the public, because what the public hears on every day on television from the media is the voice of the fossil fuel industry, which tells them that there are jobs associated with pipelines from Canada. It's actually a very small number of jobs. We would have much better and more jobs associated with moving from fossil fuel industry to clean energies of the future. And that would be in the interests of our national security, in the best interest of our economic development, and the issue of intergenerational justice, as well as justice for other developing parts of the world. And It's actually a bright picture if we would simply make the system honest. And so that there would be, and then the actions that individuals could take would make sense and would move us in that direction. At present, if you decide to reduce your fossil fuel use, all that does is reduce the demand for the fuel, make the price less, and somebody else will burn it. We have to put the price on carbon to make it pay its cost to society. If we don't do that, we're going to stay addicted to fossil fuels. So it's not that hard to understand, but we need to have a president, explain this to the public instead of our governments, which are well-oiled and coal-fired, and they simply are able to keep the system going for their profits. We've got to have a system that works for the people instead of the fossil fuel industry. Thanks.
Thank you. Thanks, Jim. Our next speaker is another individual who I've learned from, and I'm very pleased to introduce Susan Solomon, who is now the Ellen Swallow Richards Professor of Atmospheric Chemistry and Climate Science at MIT. She was formerly head of one of the climate science groups at the NOAA. And she, as I alluded to earlier, her work has been very important, but for me at least, really hit me. Her work and the lecture she gave to the Bulletin demonstrated the importance of realizing the inequities, the global inequities of the people producing versus the people suffering from climate change. Now, Susan's many awards include the National Medal of Science, and of course she shared, along with the other members of the IPCC, the Nobel Peace Prize. And what I learned was that recently two things about her. She has an Antarctic glacier named after her, and therefore she has a personal reason for it occurred to me that for her children and grandchildren, that if it's still going to be there, we have to fight climate change. And the other thing I would say is, if you admire the lovely jewelry she's wearing, I learned that she makes her own jewelry. So there we go.
Thank you. Well, thank you for a very flattering introduction. It's a pleasure to be here, and thanks to all of you for coming out tonight for this. It's just incredible to see such a great crowd. I want to talk to you tonight about a few things, and I'm at the end going to ask you to try to remember them and pass them on to someone else. I'm going to start talking about the history of carbon dioxide in our atmosphere. This is showing you the carbon dioxide of the last 10,000 years only. And what's amazing to me is you can see how back in the day, 10,000 years ago or so, when these kind of creatures were on our planet, we had about that much carbon dioxide. And then when the Romans built the Colosseum, we had about that much. And then along came the Industrial Revolution, and you can see the remarkable increase that's happened. And what that's doing to our planet is to change the energy budget. It's a gas that affects the way that energy gets in and out of our planet, and that's a forcing that's causing our climate to change. Energy use is embedded throughout modern society. As we burn fossil fuels, our collective emissions are what's causing this tremendous rise, which is clearly unprecedented in more than 10,000 years, as you can see here. Lawrence mentioned the fact that the warming that we're producing from that carbon dioxide increase is essentially irreversible, and I want to talk just a little bit about that. I did some work on this a few years ago, and it really opened my eyes to the problem. We've been increasing CO2, as I've just shown you. If we were to keep going to some level, 450, 550, 650, we're currently at about 390. From the background value of 270. If we keep going up to whatever level you want and then just stop, carbon dioxide decays away rather slowly over the next many thousands of years. I'm just showing you the next 1,000 here. But this is what the warming does. The warming stays almost constant. Doesn't really matter what level you get to, that's what you're going to be stuck with for essentially at least 1,000 years. So it's to first order then irreversible on human timescales. And the reason for that is really cool. It's actually the fact that our ocean is taking up a lot of heat. And so there's, if you will, a sort of a thermal lag on the system. It can't cool down very quickly. You've made hot water on the stove. Even after you turn down the burner, the water stays hot, and the air above it will also stay hot much longer than air would do without that water there. And that's really the key driver of what's going on, coupled with the fact that it takes so long for that carbon dioxide to get into the ocean and into other sinks that exist. So basically, everything that we've already done is largely irreversible for at least 1,000 years. So for those of you that are students, I see a lot of students out there, most of this problem is really so far caused by what people have admitted in the past, which means you can blame your parents for climate change, which is great, isn't it? Now, in terms of what happens in Arizona, and other parts of the West, I think every part of our world has a different key impact that we worry about. But for me, in the West, I think the biggest problem is the increases in wildfire. If we look at wildfire burning, the area burned in Western Canada, where the lands are essentially unmanaged, so you can't blame this on, forest management or something like that. As the Western Canadian regions have warmed, the area of wildfire burned has increased. There was a recent report from looking at the Forest Service data that showed that actually in Arizona you've had quite a substantial increase in area burned in the last 30 years because it's gotten warmer here. Well, if it were to keep getting warmer, let's say it were to warm another 1 degree Celsius or 1.8 degrees Fahrenheit, you would expect to see increases of something like a factor of 5 in the area burned in parts of Arizona and parts of Colorado and Idaho, places like that. So it's really quite an incredible increase, a factor of 5 more acres burned per year for that kind of warming. So who's causing this to happen? I know this is a little hard to see. This is just showing you how many tons per person per year are emitted around the world. And the good news is that we are not actually number one. The countries like the Emirates and Qatar and places like that emit considerably more than we do. We kind of trade places with Australia and Canada. From one year to another, they might be ahead of us or behind us. And we look at a graph like this, and we look at these countries down here, which I know this is hard to see, but it's places like Ghana and Nicaragua and Zambia and Ethiopia, and we just say, well, they really don't emit very much, do they? And I think it's important to ask the question, how much do they emit? So what I did is to make this graph, which is the ratio of our American per person emission to that of the other country. You'll notice Chad, the number is 1,000. That means we Americans emit 1,000 times more than the average person in Chad. So every one of us is 1,000 Chadians. Ethiopia, it's more like a factor of 200. Kenya, it's about 80. When I flew here from Boston, when I fly home, I will have emitted in that one trip about as much as the average Kenyan does in a year. And I do it a lot more than once a year, I can tell you. So you can go down the list and you can really see the tremendous disparity in emission worldwide. People who live like this just don't emit carbon the way people who live like that or like that do. And if you go around the world and take the average, the 6 billion people who are now in the developing world actually emit about 5 times less fossil fuel carbon per person than the 1 billion of us that are lucky enough to live in the developed world. And I think it's incumbent on us to pose the ethical question, what about those people's future? If they develop as we develop, the planet is going to get extremely hot indeed. It's even worse than you might think, because this is what CO2 has done over time. This is what the emissions of carbon dioxide have done over time. So there's the Industrial Revolution with the millions of tons of carbon increasing. And if you ask the average MIT graduate student what it would take to stabilize the level of carbon dioxide, in other words, to keep the carbon from continuing to shoot up, they would say that you'd have to stabilize the emissions, keep them constant. And that would be the wrong answer, MIT graduate student. The right answer has to do with the fact that the carbon dioxide in our atmosphere, it's kind of like the water in a bathtub. We're putting it in, the faucet is putting it in at a rate about twice as fast as the drain can take it away. So if we kept putting it in at the same rate, the water in the bathtub would keep rising. If we wanted it to stop rising, we would have to decrease it so that the drain and the faucet matched better. But the bad news is that actually that would take a reduction of at least 50 to 80%. Be 50% for a few decades, and then it would have to go to about 80% for reasons I don't have time to explain. But the disturbing thing, I guess, about that is when you think about it, we need an 80% reduction in emission. And that just really, to my mind, though, it's a little bit liberating because it tells you this is a very big problem. It's much bigger than whether or not you take the bus or do other things that you might do to try to reduce carbon. I'm not telling you not to do those things, but I'm telling you that what's more important than those things is to actually understand this and help spread the word about it, because this is going to get a lot worse. What about those 6/7 of the people on the planet currently emitting 5 times less per person than the other 1/7? If they use carbon as we use carbon, the faucet and the drain are going to get like this, and our temperature on our planet by 2050 or 2100 is going to reach levels that, frankly, are simply uninhabitable. I mean, something like 10 degrees Fahrenheit warmer in Phoenix in the summer would be pretty hard to take. So is it too late? It's actually not too late. The emissions of the future from the things we already have would lead us to about 1 to 1.5 or so degrees Celsius of further warming. That's because the infrastructure that we have will decay away if we were to make a change to something else. What really matters is the future infrastructure that's about to be built. So it's our choices, and indeed mainly choices in developing countries, that would lead to those very, very high levels. I think we need to talk more about this, and we need to decide, I think, to aim high on invention and technology, because what we need is ways to produce energy that don't emit carbon dioxide, or perhaps ways to capture the carbon dioxide. I know this is a little hard to see, so if we need all that energy and innovation, who's going to do it? The United States remains the world's top innovator. This is just showing you the invention and innovation around the world as measured in successful patents, because there's no perfect way to measure innovation, but it's one way you can do it. So countries like Japan, China, Germany, France, and the UK round out the set of the majority of the world's top innovation. And if you look at the top innovators in energy, even in renewables, we're still #1. And in nuclear energy, we're also very, very high in the innovation that's going to lead us out of this. So I'm going to let you study some of these thoughts. I think the key question that worries me is, what can people do? What can we do that's practical? It's not like recycling. That gives us a real feel-good feeling that we can go and recycle and feel like we've done something helpful. But as nice as that type of thing is to do, here we need something a little bit tougher. We need to really think about top-down emissions policies, perhaps like Jim was talking about with carbon taxes. Personally, I'm more interested in bottom-up technology policies and really ways to get engineering and innovation to do more for us. And I think we should be able to talk about those things. So there's 3 things I'd like to ask you to explain to a friend. And they are that the warming that we're doing is irreversible, but it's not unavoidable. We can choose to stop turning up the thermostat if we wish to. If we want to stop the carbon from increasing more and therefore avoid more irreversible warming, we need to reduce our emissions by 80%. Great news. You don't have to take the bus. But you do, #3, have to tell other people that we in America really, as the world's best innovators, I think, have an ethical obligation, really, to bring carbon-free energy to the rest of the world, especially the developing world that so desperately needs to change their condition. Thank you.
Okay. Thank you, Susan. Thanks, Susan. I'm pleased our next speaker to introduce is John Ashton, who is a diplomat, or a former diplomat, and he formerly served as the UK's Foreign Office Special Representative for Climate Change and led its Environmental Policy Department, and took key part in the first UN security debate on climate change. He now runs a nonprofit interested in working ways to accelerate the transition to sustainable development. We also represented for us recently. Some of you may have heard him on the radio. He's here at Science Friday. Had a special edition on Friday about climate change because of the event we're having here, and John represented us well. I've learned that he is a former physicist, and he's very embarrassed about the fact that he left physics to become a diplomat, in particular because all of his friends left physics to become Wall Street quants, and they're all much richer than him now. It's, as embarrassed as he is about having left to be a part of physicists, for reasons that I can't quite understand, he's nevertheless equally proud of having maintained an active cricket career. And as someone who's been forced to watch cricket on numerous occasions, that still mystifies me. But in any case.
Thank you, Lawrence. For the last 100 years, the United States of America has been the strongest, the wealthiest, the most inventive country in the world. It's been the country where the future isn't something that happens to you. The future is something that you build. It's the country where, in the poetic words of President Obama that November night just over 4 years ago, the country where you bend the arc of history. And all of that has been based on a single wonderful idea. And that's the idea that you can use the powers of reason that we have been endowed with, inspired by curiosity, informed by science, to make the future better, to build better lives, to, if you're a parent, to say to your children that the most important legacy I can give to you is a better prospect, a better set of opportunities than I had. By reason, let me be clear, I don't mean what passes for reason in the so-called rational agent models of economists. What I mean is the idea that there is such a thing as reality, and that it's not a bad thing to pay some attention to reality and to set your compass by it. That's what I mean by reason. I started to come to America as a child in the 1960s, and I still remember the sense, even as a child, it was in the air. You could bottle it. And I took some of it back to London, this sense that you could use reason to drive progress, to make your lives better. And that's, more than anything else, that's what led me to choose that career in science, from which I, with indecent haste, defected into the more murky world of politics and diplomacy. And please, all of you scientists in the audience, please forgive me for that. It seems to me that the argument that you're having in this country about climate change is not really an argument, certainly not only an argument, about climate change. What it actually is an argument about the place in society, the place in politics of progress and reason, and you want to keep using this compass to build your future, the compass that has made you the strongest country in the world for the last 100 years. Do you want to be a country that is still making reality-based choices even when they feel hard? Or do you want to be a country which is pretending that reality is something else so that you can make choices that feel easier? A famous American journalist, Ron Susskind, reported during the time of the first administration of Bush the Younger that he was telephoned by an official from the White House who complained about an article that he'd written, and the official said, "You belong to what we call the reality-based community. We despise the reality-based community. We make We make our own reality. And just in case you're thinking that that was from another era, I was so taken with the remarks in the letter that was published yesterday by Energy Secretary Stephen Chu, explaining his decision to resign, where he said he thought that the final arbiter of any position should be experimentation that seeks unbiased truth. Now, I don't think that your Energy Secretary would have said that in a public letter if he thought there was a national consensus that that is indeed how we should arbitrate any position. I think the only reason I can think of why he wanted to say that was because he felt that that idea might be under attack. And I'm told, I've even been told on this visit, quite often when I come to this country, that this whole thing about climate change is a conspiracy by science to raise money. Conspiracy by science to raise money. And that makes me so sad to hear that, because your science in this country has been your beating heart. It's your science that has, more than anything else, delivered this progress. And to turn on your science in that way is like an organism turning on itself. It's like an autoimmune disease. In the case of climate change, paying attention to reality, we know what to do. It's not rocket science, as they say. This is, as others have said, this is about building a carbon-neutral energy system, taking carbon emissions out of the electricity system, out of transport, out of heating, and on the demand side, doing the whole thing a lot more efficiently. And when we do it, what it will feel like is a new golden age of electricity, using electricity to do more things in smarter ways, while at the same time making our electricity system carbon neutral. And I lose count of the number of times that I get told that that's an impossible thing to do. But when you hear somebody tell you something's impossible, be very careful to understand. Are they telling you that it's thermodynamically impossible? That it's impossible in terms of engineering and technology? If that's really the message, and if it's right, then it really is impossible. But quite often when you hear that word, what they're telling you is that it's politically impossible. And that's a completely different thing. And then you have to say, well, what is the interest of the person who's telling me that? Do they want this change to happen or do they not? I get told again and again that making this transition rapidly is going to be so damaging for jobs, for growth, for the state of the economy. But as I look around the world, the countries that are really investing effort and capital and making progress with this, countries like Germany, like South Korea, like China, actually, which is not always understood around the world. Those are countries which are not among the most spectacular economic failures in the world at the moment. They don't seem to be killing too many jobs by taking a forward position on building a low-carbon economy. Even Britain, whose current government, which I worked for a while, but no longer do, whose current government is exploring the exotic territory of a triple-dip recession. So our economy is shrinking now, it's not growing. But the low-carbon economy in Britain is growing by 4%, nearly 4%. So that tells you something about the limits of the possible. Right now, and it pains me to say this, around the world, wherever I go, the perception is that the United States, this great country, is not a leader in this enterprise. The United States is a follower. The Chinese government has just announced that it plans to install 10 gigawatts, the equivalent of 10 large power stations of new solar energy capacity in China this year. Last year, the United States installed 1.8 gigawatts, smaller than 2 large power stations. That's just a calibration, a comparison. And I say all of this not because I want to criticize, to scold, to lecture. It's not for me, a visitor, to do that. But I want to underline the very close links I have with this country. My mother spent her childhood in the Brandywine Valley. I have a second family in America. Throughout my childhood and then my entire career, I have been close to America in all kinds of ways. This is a country that I love, and so it makes me really sad to see this country that should be a leader in everything being regarded around the world as a follower. So what I say is, please carry on having the argument about climate change, but as you do it, as you conduct that argument, be aware that this argument reaches in to a much deeper rift, which is not an argument on what to do about climate change, it's an argument on who you want to be as a nation. And conduct yourselves so that you can win that argument, because unless you get the right clarity about who you want to be, you're not going to do enough of what you need to do quickly enough to make a difference. And when you're told that building a carbon-neutral economy very quickly is impossible, don't say, well, let's do something else. Say, let's expand the limits of the possible. Why is it that the other side gets to set where those limits are in this argument? The other side has been much smarter in the politics of this. And if you decide that's what you're going to do, then don't say to the world, this is what you must do. Say to the world, this is what we're going to do, because there's no great transformation that has ever happened in human societies anywhere which has been driven by one group of people telling another group of people what they should do. I think I don't know whether there are any Buddhists in the audience, but the Buddhists have a saying, change comes from within. And in this case, it's right. And at the moment, your many friends, your oh so numerous friends around the world are sad because they don't hear you saying those things and asking those questions. And I think it's time for the reality-based community now to start fighting back. And I think climate change is the issue where that fight back is going to start and where it's going to succeed. And I think by doing that, that is how America, how all of us actually, regain control in these turbulent, anxious times, regain control of our destiny. And before I sit down again, I just want to say one other thing, which is a personal tribute to Wally Broecker, because I wouldn't be here tonight. I wouldn't have spent the last 15 years of my life concentrating on this issue without Wally's encouragement. And Wally, if this was Japan, Wally would be regarded as a national living treasure. He may or may not be the godfather of climate change, but he's certainly the king of the carbon cycle, and he's one of the great reality-based Americans, and he's my friend, and I'm very proud that I'm his friend too. Thank you very much.
Thank you, John. Well, I'm very proud that our next speaker is a friend of mine, as a matter of fact, Sander van der Leeuw, who's not only the dean of our School of Sustainability, but a distinguished archaeologist and historian, and it has been a guide to me since, in many ways, telling me what I shouldn't do often and always being right about it. Since I've come here, helped guide me and helped been an advisor to the Origins Project. So I admire him tremendously. So do other people. In fact, of all the people on the panel, Sander is the only champion of the Earth. The United Nations awarded him one of its titles for Champion of the Earth. It's a top environmental award for his work on understanding innovation as a social process and its environmental impact. Sander was talking to me, and not only is an archaeologist, an anthropologist, and he's going to talk in that context here, I think, because as an anthropologist who's visited Syria and the Philippines, he's watched societies change and the impact on change in societies. And really, in some sense, this issue of climate change will be, for the industrialized world, a study in societal change. So, Sander.
Okay, thank you. Thank you, Lawrence. Thank you, Wally. I can't say that I've known you for so long. I only met you last year. But it did make a difference immediately. And one of the results is that I actually feel relatively good about being in a conference on climate. Because I had a very bad experience in 1996. I attended my first climate conference, and I heard people in 20 minutes come up with 6 different climate scenarios that differed about 0.2 of a degree in 2030. And my reaction was to say, look, folks, that's very nice, but humans have dealt with much bigger changes. Why don't you look at how humans can deal with this? Well, the sad part of the story is that it is the only conference in my life where I was officially refused to further contribute in writing or in the discussion. And so I felt a little bit strange, and if it hadn't been for Wally's encouragement, I'm not sure that I would have accepted this invitation. But they're much nicer here. That much I can say. I attended today, and it was a very pleasant and incredibly informative day. I come to this topic actually because of a sort of a contradiction that I began to realize. If you look at the political world and the news world, people talk a lot about we have to innovate our way out of trouble. And as a historian, I began to realize more and more, and Susan has illustrated that for you in a graph, that I think actually we innovated our way into trouble. And that has been happening due to a huge acceleration of innovation since the beginning of the Industrial Revolution, which was actually facilitated by the discovery of fossil energy and its increasing use, so that in many ways it became a lot cheaper to start innovating. So we need to change. That change is a collective action problem. It's a collective action problem which is in itself even more difficult than usual, because we have to fight with ourselves. This is not a war with an enemy. This is a war in which we ourselves need to find that fixed point outside our ideas that will make us change our minds. The current crisis in sustainability is actually not only a climate crisis, and I hope my climate friends will forgive me for underlining that, and saying it is tied to a financial crisis, it is tied to a social crisis, and to many other crises. And what ties it in my mind is the idea that we are being overcome by the unintended consequences of our own actions. Every time that we undertake an action that relates to the environment, we do that on a relatively simple view of what goes on, simply because we cannot, in our heads or collectively, integrate all the many dimensions of a problem like that. Yet when we act upon the environment, we touch on all those dimensions that we don't know. And so ultimately, what happens is that we create so many unintended consequences that we get a hard time dealing with them. So one of the things that I think is really important here, and that is what I want to say about innovation, is that we start, when we innovate, to think much more deeply and constructively about what the potential consequences of our innovations can be. And seeing how that worked out today, you begin to realize how incredibly complex this issue actually is if you deal with it at the level of the dynamics concerned. I would argue that more in general, our society needs to think more about future consequences of our actions. And I'm always struck by the fact that in the sustainability debate, we basically have never had a debate about what kind of future we want. We have a debate about what we want, what we don't want, how we can remedy certain things, but there is no coherent debate about what our future might look like so that we can actually try and make informed decisions. Now I want to make a brief comparison, as an anthropologist in this case, between the United States and Europe. Because coming from Europe, it strikes me that the European culture and the American culture differ in one major aspect. And that is that Europe has for a much longer time had to live within its resource means. The basis of the American dream is effectively that there are unlimited resources and that anyone, therefore, can attain any summit that he or she might like and wants to work towards. That is a difference. There are many others with many other cultures. The Chinese, right now, have a much longer time perspective than we do, and that shows in the way they manage their politics. In a funny way, and Lawrence will forgive me for that, this also touches on the relationship between perception and observation. Yes, the facts that we're talking about here are true, but we actually need to see how individuals see them, what for them is the truth in them. And I'll get back to that in a little while. One of the major roles that I think we have not, as academics, fulfilled is actually to listen. All day today we talked about communication, but most of the time, except for one or two, we did that from the standpoint, which is the traditional academic standpoint. We perorate, the others better listen, and they better understand what we're saying. Well, it never works like that. And so more and more here at ASU, we are beginning to look in the whole problem of sustainability communication. The message that many scientists have proclaimed for so long now isn't always heard in a particular way. Sometimes because it's not directed at the particular audience that it is for, or it's misdirected, or the wrong words are being used. In other cases, it is because science, in certain circles, has lost a lot of credibility. And we can go into the reasons for that at some other occasion, but they're quite important and relevant reasons. So I would argue, first of all, that the problem that we're dealing with is not in the environment itself, but that it is actually a societal problem. After all, we define our environment, we define its challenges, and we define its solutions, or what we think are the solutions for those challenges. And in doing so, we don't really communicate with the environment. We don't ask its opinion. We say, well, this is a fact, and this is how it goes. As a result, but not only of this, I would argue that the social sciences have been way too little involved in what we are doing. We need to start exploring, as social scientists, how people look at this, how the dynamics work in society, and how we might actually work to change those dynamics. And in order to do that, we need to listen and to understand. It is for that reason that we have just created here what we call a climate adaptation center, or with a much longer word that I don't remember. But basically, what is it all about? It is on the one hand to help people understand what is hanging over their heads. But for us, much more importantly, it is for us to understand what their questions are, what their problems are, what they think they need to do, and how they perceive things. And that then brings me in a different way to the role of education. One of the people today in the symposium argued that the universities had not fulfilled their role, and I wholeheartedly agree. I've just said so. But I think it goes much deeper. I think one of the things as a society we do poorly is to educate children very early in the fact that there are alternatives, that people have to make up their mind about those alternatives. In fact, what happens most of the time in, let's say, kindergarten or just after, is that the teacher has a choice between two things: stimulate independent thinking and create social interaction, that is, a degree of normalizing behavior. And very often, that last is actually the easiest, and therefore the thing that is done most. As a result, few people have actually the tools to make those decisions, to have critical thinking. And that, I think, is what is one of the major issues why it has been possible that in the political world in this country, the polarization has actually torn the sustainability debate apart and created the immobility that we see at this point. I would maybe end by basically saying We need to take that future back. We need to take it back from the media. We need to take it back from the politicians. A film that was produced by somebody who we very recently hired here at ASU, a man called Peter Bike, who some of you may have seen about a week ago in our Future of Energy debate, has created a film called Carbon Nation. And he does, by interviews, show how if you put the debate in the terms of the people you're talking to, virtually everybody agrees that this needs to be done. And I think that is a really important lesson to take away. We need to tune our message. We need to do much better at that kind of game if we are to do this. Thank you very much.
Thank you, Sander. Thank you. Well, the next speaker is not Wally Broecker, in spite of the fact it's on your program, and there's a reason for this. After we got to know each other a year ago when Wally was here visiting and we talked about this, and so he got to know me well, he looked at me and said that the smartest person he knew was Klaus Lackner. I decided not to hold that against Klaus. And we were very happy that he's here. And Wally asked if Klaus could replace him on the panel. Klaus is the Ewing Wurtzel Professor of Geophysics and Director of the Center for Sustainable Energy at Columbia's Earth Institute. He, interestingly enough, was trained as a theoretical particle physicist. And he was telling me that he was working on some ideas, but he didn't want to wait 200 years till they were tested. I think that's particularly poignant because we've been talking about things to do, and we've been talking about communication and innovation, but we haven't been specific about it. And I think it's appropriate to end the panel here with Klaus, who's actually involved in a team that's exploring and developing an air extractor to try and remove carbon from the atmosphere in real time, modeled after a tree leaf. And I assume that Klaus is hoping that that idea won't wait 200 years to be tested. So, Klaus.
Thank you very much for this introduction, and thank you, Wally, too. I remember many, many years ago in the 90s, I was in Canada giving a talk, and you went home because I have friends now at Columbia who said, that was a really crazy guy, but then you hired me, and so now you're stuck with me, and thanks for letting me stand in, and you all need to know he has an enormous amount of energy. He just has gone through heart surgery, and so I understand that he looks for somebody else, but I can't fill your shoes on climate change. So let me talk about the things I am doing, which is engineering on the same problem. And even though I'm a theoretical physicist, I ended up in an engineering school trying to solve the problem of climate change from the other end. So in a way, I'm a consumer of climate science, and I'm asking the question, what can we actually do about it? What is the best way of dealing with this problem? And so the first question is, what is the problem to be solved? And it's quite clear that the world needs probably more energy than it has today, because, as you heard before, 1 billion people on this planet do very well in their lifestyle, and they consume an awful lot of energy, but there are 6 billion others who don't have it yet, and we probably will be a little more. So over the century, you may see 10 billion people who want to live like we do. And even if we get a lot more energy efficient than we are today, and everybody predicts all that energy efficiency, we will likely consume a lot more energy than before. But at the same time, and this is what struck me very early about it, it's sort of nearly irrelevant to argue, should we stop at 300 or 350 parts per million in the atmosphere? We are now at 400, and we are going up every year by several ppm. So where should we stop? And the funny thing is, it doesn't matter as much from the engineering perspective, because once you tell me we are close to the point where we need to stop, I will tell you the only way to really practically get there is not to emit any CO2. So we see in the future an energy revolution which has to happen, which makes the system carbon neutral. Somehow or another, we have to get the energy we need without emitting CO2. And the question is this doable? Well, if you want to use fossil fuels, then you will have a very simple rule. For every ton of carbon coming out of the ground, another ton of carbon will have to go back in. We convert this from fossil carbon into CO2, but we cannot afford putting it in the atmosphere, so we have to close the cycle. The alternative is, if this gets all too expensive, we have to figure out how to live on other forms of energy, but those better be big because they have to replace more energy than we consume today. So if you start looking at over the horizon what big energy sources we have, I can see nuclear energy, maybe with fusion over 100 years, and that's an interesting option we should work on very hard. We probably should try solar energy because there are 100,000 times more, there's 10,000 times more energy from solar energy than we consume right now. We could tap into this and have plenty of energy. And ultimately, there is an awful lot of fossil carbon. There is so much coal, there's, as you heard from Jim before, there is so much fossil carbon that it doesn't run out. And being the engineer, I would argue, it's also probably by far the most cheapest you can think of. So it will stare us in the face and say, use me, it's easy. And then the answer has to be, if you use it, you have to have carbon capture and storage. It's the only way you can close that cycle. So I'm not in the position here to tell you we have to stop using energy, and certainly not even fossil energy, but if we want to use it, we have to close the carbon cycle and put that carbon back. And there's no question that will cost money. It's not coming for free. But on the other hand, there's lots of damages which come with all of that use right now, and I think it's going to be a lot cheaper than that. So I hope that at the end of the day, we can do this for maybe $30 per ton of CO2 or $50 a ton of CO2. That depends in part also how much a dollar is worth in 100 years from now. But whatever that number will be, in today's days, this is a few cents more on the kilowatt hour and maybe 30, 40 cents more on a gallon of gasoline. And for that, the problem from an engineering perspective is probably solvable. So from the engineering perspective, we now need to figure out several options. I do believe we have to work on energy, on nuclear and solar, and on carbon capture and storage. And these are three big bets we place, and we better win one. Because if we lose all three, we are in real, real trouble. So right now, I have focused on the carbon capture and storage bet. The first thing is you need to have a place to put the carbon dioxide. Now, if I started in the 1995 time frame, I argued I do want to make mineral carbonates out of it because there's lots of calcium carbonate rocks, there are magnesium rocks, and if I can take other rocks and bind the CO2 to it, that's a great way of putting it away. I still believe that's the best option, but in the meantime, it has become pretty clear you can inject an awful lot of carbon dioxide into the ground, and while I still think in the end you need better options, in the short term it took away every excuse that we don't know where to put carbon. We can put it away. So let's start thinking about it. The second thing is you can get the carbon dioxide back from power plants. As a matter of fact, people have done this in the past because they wanted the CO2 and sell it, maybe to make fizzy drinks, maybe to make dry ice, but they have taken it out, and so we know it can be done. It will cost some money. It can be done. We will do this at some level. But roughly half of all of the emissions we have actually don't come from the big point sources. If you fly, like I came from New York, I came on an airplane, they can't fly without jet fuel. You couldn't lift the batteries. As a matter of fact, you couldn't even capture the CO2 and put it on board of the airplane because it weighs 3 times as much as the jet fuel. Even if I could figure out how to do it, I couldn't carry it home. So as a result, there will be a large number of emissions which are very, very hard to stop. And so that made me start thinking about, couldn't I get it back out of the air? And the first response everybody had, including myself, that's way too difficult. This is very hard to do because the CO2 in the air is so dilute. And then I started to calculate it a little, and I realized there's actually an awful lot of CO2 in the air. If you take a cubic meter, sort of 3 feet by 3 feet by 3 feet, there's about half a liter, half a quart of CO2 in that box, in every such box. So just like you have windmills standing in the wind and collecting wind energy, you could have devices stand in the wind where the air blows through and it has to give up its CO2. It's like the leaves on a tree. As the air blows over it, the CO2 sticks to these surfaces. And I convinced myself, after some thinking about it, that part of the problem is actually relatively cheap. The hard part is I had to bind the CO2 to something, and now I have to pry it back loose. And now I can look at what the people did for scrubbing flue gases. They have a sorbent which can do this. They could pry it loose, and that costs about $10, $20, $30 a ton of CO2. We think we have to be a little more expensive because we have to hold on a little more tightly because the air is more dilute. But it's not orders of magnitude more. It's about a factor 2 or so more tightly bound, and therefore our energy consumption will be roughly twice as high as they are if they are perfect, but they aren't perfect either. So overall, we will be costing a little more than capturing at a power plant. But I think it is doable. And so people said, well, what would it cost? And I said, well, it's very hard to say what things will cost if they are brand new. And right now I'm arguing people have looked at specific processes which are $600,000 a ton. Those are out of the question. If you're below $100 a ton, it gets interesting. At $30 a ton, it would be 25 cents on the gallon. So if you get below $100, you can start thinking about this problem as a solution. We think this is in the cards right now, and you would build devices which are like the first Model T. They are very expensive, they are hand-built, and if you now start mass producing them and really learn how to manufacture them, prices will come down from there. So we believe this is feasible, and in the meantime, we said, well, it has to be passive. We have to stand in the wind. We have to be clever about it. Standard technologies from refineries, they will not work. They will be too expensive to separate gases. So you have to think about it as a brand new problem, like the Wright brothers had to think about aviation. Everybody told them, well, heavier than air flight is not possible. I'm stressing that is because physically it's possible, but from an engineering perspective, it's very difficult. And so engineers who build locomotives will tell you, I can never make that thing light enough, and I certainly don't know how to land on a track. So here too, you have to start thinking about the problem from scratch. And so we said, well, these are passive devices. They are more akin to trees than packed beds in a plant, in a factory. And so they touch the CO2, they are put in a box, and we developed a material which has the remarkable feature that if it's dry, it loads itself up with CO2, and if you make it wet, it gives it back. And it pushes it back at about 5% CO2 in the concentration in the air, which now takes it out. So we basically converted CO2 from the air into CO2, which looks like flue gas. And we can do this probably for $30 a ton. We don't really know that until we really have built a big device where we can kick the tires. And then how cheap it will get then, we don't really know. I give you an example. Wind energy today is 40 times cheaper than it was in the 1960s. Solar energy is 100 times cheaper than it was back then. So the early prices are difficult to translate into where it really will end up. So in summary, I would say we have to give it a try. We have to demonstrate it. We have to ideally find applications where people could use it. But now think about it. I could have CO2 and collect it in Nevada and take care of a car in New York. Or for that matter, I could take care of CO2 emitted in Tokyo in Australia, because the air is just carrying it all around, and it doesn't really matter that it was emitted there and was in the air for a few months or even a year before it got picked up on the other side. So it becomes a bookkeeping effort. As long as we take as much out as we put in, the system stays in balance, and nothing really prevents you from getting bigger than that in the end. We have designed a box which is about 1 ton a day, which would fit into a container ship. And if you had 100 million of them, you would actually pull more CO2 out of the air than we put in. To just give you a comparison, Shanghai Harbor processes 25 million containers every year. So that sets the scale. It is a scale you could, in principle, do. And my view is we have to get started and get to do something about it and clean up after ourselves. It's perfectly fine to have energy, but we have to clean up after ourselves, and it's just like the sewage systems in the past. We cannot afford to just ignore the slop and send it on the street. We have to pick up after ourselves, and then we can have the energy as well. And I'm 100% in agreement with John, with inventiveness and the willingness to solve the problem. We also can get over the action problem and actually solve it and get it done. Thank you.
Thank you. Well, I want to thank the panel. There's a lot of food for thought there. I hope that you have a lot of food for thought, and I'm going to come up with some questions. And then we're going to take a break in a minute, and and then we'll come back and I'll be asking the panelists some questions. Before we do, Wally's here, and as I say, Wally was one of the first people to point out the importance of the oceans and the climate, and he's standing, and I would like to ask if you wanted to add a word or two, because I must say that I know that as attractive as Arizona is in the wintertime, and as attractive as the Origins Project is, that one of the reasons we were able to get the major scientists in the world here is because Wally, I have learned, doesn't take no for an answer. So, Wally.
Well, it's a pleasure to be here. A month ago, I wasn't sure I would be anywhere. I had quite a time being opened up and worked on. I'm really pleased that what we did today came off as it did. I got the idea of inviting people to this, and I sent out emails, and I was amazed that I got 100% response saying, yes, we will come to such a meeting. And people are kind of amazed because the people who agreed are busy people, and they get tired of going to meetings. A little bit about my own history. I got my PhD the same year that Charles David Keeling started his Hawaii measurements, and I've been interested in the carbon cycle, and I followed that closely. And one thing that concerned me was that between 1958 and 1975, even though CO2 was going up steadily, there was no warming. And so I pondered why this might be, and based on some measurements that were made on ice cores in Greenland, I decided it was because there was a natural cooling that was sort of balancing out the CO2 warming. And I got the idea this was cyclic based on the Greenland records. And if that were true, we should be approaching time when nature turned around and started to warm. So I wrote a paper entitled, Are We on the Brink of a Pronounced Global Warming? And that was published in Science in 1975. In 1976, the warming began, and I looked very good, except the logic I used in the paper was all wrong. Nobody's found these cycles in any other record. But anyway, I was punished for this by being given the title Father of Global Warming. And that's certainly, that title should go, I think, to Jim or to Charles David Keeling. Okay, so I wrote that article in 75. It's been 37 years since then, and very little has happened. So I'm concerned that in the next 40 years, unless there's a dramatic turnaround, things are going to go slowly. And this transition to utopia of renewable energies may take a very long time. During that time, we're going to be pouring CO2 into the atmosphere. And therefore, I think what Klaus Lochner here is doing is enormously important. And we should all pray that air capture will be something that we can do environmentally safely and economically reasonable price. The tragedy is that even though Klaus knows how to do it, in 13 years he's never been able to raise the money from any source to make a true prototype, which is sort of necessary if you're going to make a real evaluation of the costs. He's received, and I know something about this, something like $8 or $9 million over this time. And there are a couple other people, David Keith and Eisenberger, who have similar enterprises. I don't know what kind of money they've raised, but probably not as much as Klaus. What Klaus has raised is what a Yankee pitcher who wins maybe 5 games can make in 1 year. And you know, there's something wrong. That this could be the salvation of our planet, and yet, you know, the amount of money that's going into it is minuscule. The venture capitalists won't touch it because it's too long range. Industry, of course, is basically against it, or the fossil fuel energy, and governments have not stepped forward. I think that one thing that has to be emphasized is that Obama administration finds money to do this. I mean, we're talking about peanuts. And, but if we can't do this, I think we're in terrible, terrible trouble. We're entering a CO2 trap. So this is all I want to say. I'm very pleased with what I heard. I was wondering when we did the rehearsal how well it would go. But I think all the speakers did a good job. And I'm glad that Klaus was able to have a full chair there. And I could sit in the audience. So thank you for coming. And we'll have a break now and then some questions.
Yeah, let's take a break. Thank you very much. Thanks a lot, Wally. Thank you, everyone. Be back in a few minutes.